Hypothesis testing, the null and alternative hypotheses. Our objective, determine the null and the alternative hypotheses. Okay, so what is a hypothesis? It is a statement regarding a characteristic of a population. Okay, we'll be looking at hypotheses regarding a single population parameter, either the population mean, mu, and again, this will be for quantitative data, or the population proportion, p, and this will be for qualitative data. In simple terms, hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of a population. So what is the process? The process is fairly simple. We're going to make a statement regarding the nature of the population. We're going to collect evidence, our sample data, to test the statement, and then we're going to analyze the data to assess the plausibility of the statement. Okay, there are two hypotheses for all hypothesis tests: the null hypothesis and the alternative hypothesis. Let's deal with them here separately. The null hypothesis, its math notation is H sub 0, which is read H naught or H sub 0. It is a statement to be tested. It is a statement of no change, no effect, or no difference. Mathematically, it always uses the equal to symbol. And the null hypothesis is assumed to be true until the evidence indicates otherwise. Okay, the second is the alternative hypothesis. It is denoted H sub 1 or H sub A of course standing for alternative. We are trying to find evidence to support it. Okay, so it uses the not equal to symbol, the less than symbol, or the greater than symbol. Key here, and I would mark this maybe with a highlighter or a star, all of our conclusions will be written in terms of the of the alternative hypothesis. All conclusions we're going to write are written in terms of this hypothesis, the alternative hypothesis. Okay, let's continue here. Just give me just a moment. Okay, there are three ways to set up hypotheses. The first is an equal hypothesis versus a not equal hypothesis. This is also called a two-tailed test or a two-sided test. So H sub 0, the parameter equals some value in every single test. H sub 0, the parameter equals some value, the null hypothesis. The alternative hypothesis in a two-tailed or a two-sided test is that the parameter does not equal some value. Okay, your second way of setting up hypotheses, you have an equal hypothesis, again, that's your null, versus a less than hypothesis, which is left-tailed or a left-sided test. Notice the less than symbol points to the left, hence it's left-tailed or left-sided. Again, your null hypothesis is the parameter equals some value. That's always the case with the null hypothesis. The alternative hypothesis is that the parameter is less than some value. And here I've noted the direction of the inequality sign points to the left, hence left-tailed or left-sided. And the third way to set up a hypothesis, you have an equal hypothesis versus a greater than hypothesis, which is a right-tailed or right-sided test. Here's your null hypothesis, always assumed to be true, parameter equals some value. And here's your alternative hypothesis in a right-tailed or right-sided test. The parameter is greater than some value. Note here as well as here, the direction of the inequality sign points to the right in this case because it's right-tailed or right-sided. All right, an overview here of what this put this together in another way for us. The null hypothesis is a statement of no difference or a statement of status quo. It always contains the statement of equality. Look up here. Null hypothesis, parameter equals. Okay, null hypothesis, parameter equals. Null hypothesis, parameter equals. The null hypothesis always contains a statement of equality. The null hypothesis is assumed to be true until we have evidence to the contrary. We're seeking evidence to support the statement in the alternative hypothesis. And as I mentioned a few minutes ago, very important, we will always word our conclusions in terms of the alternative hypothesis. All right, let's just take a look at setting up how we set up these two hypotheses. Example 1, the Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing 2%, looks like I'm a little bit off my wording here. 2%, I think I'm going to get rid of this. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. Okay, so let's first do our null hypothesis. It is always our statement of no difference, our statement of equality. Okay, so I'm going to start it off in words. In words, our null hypothesis, of course, is H sub 0 or H sub naught. The proportion of individuals taking the new drug who experience a headache as a side effect is equal to, remember our null hypothesis, okay, is always our statement of equality, and 2% we know we can write as in proportion 0.02. So there's our null hypothesis in words. The proportion of individuals taking the new drug who experience a headache as a side effect is equal to 0.02. In symbols, whoops, I gotta learn how to spell symbols. S-Y-M-B-O-L-S. Our null hypothesis is equal, Our null hypothesis, the proportion, which should be P, is equal to 0.02. Okay, so there's our null hypothesis. What is our alternative hypothesis? Okay, in words, H sub A or H sub 1, either one. I think my lab, the homework uses one of these, and maybe the StatCrunch uses the other. So get used to seeing both A and 1 down here. The null hypothesis is always a sub 0, but you'll see A or 1 for the alternative. Okay, so the alternative hypothesis, in words, the proportion of individuals, and actually I guess these individuals would be children, taking the new drug who experience a headache as a side effect. This says is more than 0.02. Okay, because that's what it says. We're looking for more than 0.02. What is this in mathematical symbols and statistical symbols? Alternative hypothesis is the proportion is greater than 0.02. The arrow points to the right, so this is a right-sided or a this will be a right-sided or a right-tailed test. This is a, whoops, I forgot, this symbol is not equal to, made a mistake up here. No, I'm sorry, wait, I'm getting myself confused. That's equal to right there. So this is gonna be a right-sided test here for this example. Let's look at another example. This time we'll use the mean as opposed to the proportion. Okay, get myself organized. The blue book price of a used 3-year-old Chevy Corvette is $59,083. Tiana wonders if the mean price, so we've got the mean price in here, this is not a proportion, this will be a mean, of a used 3-car Chevy Corvette in the Miami area is different from $59,083. Okay, so what is our null hypothesis? Our null hypothesis is our statement of equality. Okay, so in words, okay, H sub 0 is, we're dealing with the mean, okay, so the mean price of a 3-year-old Corvette, a 3-year-old, I'm going to abbreviate here, I'll just abbreviate, 3-year-old Corvette in Miami. Whoops, if I could spell Miami, that would assist us. Is equal to the blue book price of $59,083. Okay, in symbols. Okay, in symbols we have H naught, H sub 0. The population mean mu is equal to 59,083. Our null hypothesis is always a statement of equality. Okay, what is our alternative hypothesis in this case? Okay, well, our alternative hypothesis is different from. Okay, so in words, H sub A or H sub 1. The mean price of a 3-year-old Corvette in Miami is not equal to. Okay, notice they use the words different from, so I'll just note that here, different from. It's not greater than or less than, it's different from. So it's both greater than or less than, which is not equal to, is different from the Blue Book price of $59,083. Okay, in symbols. H, alternative hypothesis, H sub A or H sub 1. The mean is not equal to 59,083. It's not equal to, so this is going to be a two-tailed, whoops, I want to write two-tailed test. A two-tailed test. Once we get there, we'll talk about how we do two-tailed tests coming up. So there you have it, a look at how we write both in words and in symbols the null hypothesis and the alternative hypothesis.